Humanity has sent probes to every planet, so we now have a decent idea of what's in our neighborhood. Even before that, astronomers tracked the movements of the solar system for millennia. Sometimes their eyes or brains played tricks. Or did they? Whatever happened to the ghost planets, those worlds that never existed or once were but are no longer? Thea? The origin of the moon was long a mystery, and, beginning in the 19th century, three competing theories emerged to solve it. In one, Earth and the moon formed together in the same spot in the primordial solar nebula. In another, the early Earth spun so fast that it hurled out a blob that became the moon. One version of this theory held that the Pacific Ocean is the hole left behind. In the third, the moon formed elsewhere but was captured by Earth. However, none of these theories could adequately explain the current Earth-Moon system. In the 1970s a new proposal emerged, that a giant impact had formed the moon. The impactor would have been the size of Mars and was given the name Thea, after the mother of Selene, the Greek moon goddess. In the impact, Thea was destroyed, and the debris became the moon. The debris may even have formed two moons, one smaller than the other. They eventually collided very slowly in what is described as something like a large landslide. The landslide side became what is now the moon's far side, and this theory would explain why the near and far sides of the moon are so different. Vulcan. This is not Mr. Spock's home planet but a world that was thought by some 19th century astronomers to be the closest planet to the Sun. Mercury's orbit precesses so that its perihelion, the point at which it is closest to the Sun, moves. French astronomer Urban Jean-Joseph Leverrier in 1859 explained the shift as being caused by one or more planets, or even an asteroid belt, very close to the Sun. He previously had discovered Neptune, in 1846, by using Newton's laws of gravity to explain the then unseen planet's effects on Uranus's orbit. Amateur astronomer Edmund Lescarbault told Leverrier that he had watched a dark spot move across the Sun on March 26, 1859. Leverrier was confident that this was one of the planets. He went ahead and named it Vulcan. However, no solid confirmation followed, and careful searches during solar eclipses turned up nothing. So what was moving the perihelion of Mercury? The problem was that Newton's laws are not a complete description of gravity. It was not until Einstein proposed general relativity in 1915 that the solution was found. In Einstein's theory, gravity is best described as a bending of spacetime around an object. Newton's laws worked well for the rest of the solar system but failed for Mercury, where the bending of spacetime by the Sun is the most pronounced among all the planets. Einstein was able to calculate the motion of Mercury's perihelion exactly, without any need for Vulcan. Super-Earths. Many stars have large rocky planets bigger than ours, dubbed super-Earths, orbiting closely with periods of 100 days or less. Our solar system has only one small planet, Mercury, with a period of 88 days, that close to the Sun. So why doesn't our solar system have any super-Earths? The answer may be because we have Jupiter. Computer models show that early in our solar system's history, Jupiter migrated inward from its current position, and, as it moved closer to the Sun, it changed the orbits of the material in the super-Earth region to be more elliptical. Had there been any super-Earths, they would have collided much more often with the material perturbed by Jupiter and, over a period of merely tens of thousands of years, would have fallen into the Sun. Mars impactor? Like the Moon, Mars has two very different sides. The relatively smooth northern hemisphere is about 6 kilometers, 4 miles, lower in elevation than the cratered highlands of the southern hemisphere. One explanation for that difference might be found in the violence of the early solar system. At about the same time that Thea might have hit Earth, a heavy body about 3,000 kilometers, 1,900 miles, across could have crashed into Mars. That object would of course have been destroyed, making Mars's northern hemisphere the largest impact crater in the solar system. Asteroid belt planet. In 1766, Prussian astronomer Johann Titius noticed that the distances of planets from the Sun seemed to follow a mathematical pattern. This finding was popularized in 1772 by German astronomer Johann Bode and became known as Bode's law. The law fit the distances of the 6 known planets, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, very well, but it also predicted that there should be a planet between Mars and Jupiter. Uranus was discovered in 1781 at close to the distance predicted for a 7th planet, giving a boost to the search for the planet beyond Mars. On January 1, 1801, Italian priest Giuseppe Piazzi found Ceres, now classified as a dwarf planet, at the expected distance. Astronomers were jubilant at the validation of Bode's law, but in the next 6 years 3 more objects, Pallas, Juno, and Vesta, were discovered in the Mars-Jupiter gap. As more of these bodies were discovered in the 19th century, it became clear that these asteroids, as they came to be called, were not planets. But what were they? Since Bode's law predicted a planet and there were only small fragments to be found, the asteroids were thought to be remnants of a planet that broke apart in a terrible cataclysm. However, that idea has not held up. The entire mass of the asteroid belt is less than the Moon, and gravitational interactions with Jupiter would not allow a planet to form there. Bode's law hasn't stood up too well, either. It didn't predict Neptune or Pluto. Nibiru. Author Zecharia Sitchin claimed in The 12th Planet, 1976, that ancient Sumerian texts revealed the existence of a planet called Nibiru, which circles the Sun every 3,600 years on a long elliptical orbit like a comet and passes between the orbits of Mars and Jupiter at its perihelion. 300,000 years ago, Nibiru's inhabitants, the Anunnaki, came to Earth to mine gold to replenish their dying atmosphere. The miners revolted, and the Anunnaki created an Anunnaki Homo erectus hybrid, Homo sapiens, to serve as slaves in the mines. This concept of a planet passing through the solar system was taken to heart by Nancy Leader, who claimed to be in mental contact with aliens who told her that a planet would soon pass close to Earth. That planet was identified by some as Nibiru. However, Sitchin disparaged this and said that Nibiru's last encounter with the inner solar system was in 556 BCE, which would place its return around 2900 CE. Nibiru took off as a conspiracy theory on the internet, where photos of other astronomical objects were presented as proof that NASA was hiding evidence that Nibiru was on its way. Nibiru then was conflated with the end of the Mayan long count on December 21, 2012, which passed without the destruction of all things, but not before astronomers tired of pointing out that, if Nibiru actually existed, it would have been seen already and that any planet with such an orbit would have likely been ejected from the solar system. Planet X. After Neptune's discovery in 1846, the search was on for another, even more distant planet, Planet X, which seemed to be perturbing the other planets' orbits. Percival Lowell dedicated his life to the search and died in 1915 disappointed. The search continued at Lowell Observatory and success came in 1930, Clyde Tombaugh found Pluto. But there was a slight problem. Pluto was much too small to explain the perturbations. Was Planet X still out there? It seemed not. With the space probe Voyager 2's much more accurate measurement of Neptune's mass, the perturbations disappeared. There was no need for Planet X analysis of the positions of the other Pioneer and Voyager probes that have left the solar system show that they haven't passed any missing planets on the way out. Astronomers are confident, based on results from the All-Sky Survey of the Wide Field Infrared Survey Explorer, WISE, that there is no planet as big as Jupiter out to 26,000 astronomical units. 1 astronomical unit, AU, is almost identical to the mean distance of Earth from the Sun, 150 million km, 93 million miles, but there might be something smaller. An analysis of the orbits of extremely distant trans-Neptunian objects shows that there could be 2 planets about the size of Earth at a distance of 200 astronomical units. Tyche. In 1999, astrophysicists John Matisse, Patrick Whitman, and Daniel Whitmire claimed that some long-period comets, those with periods of more than 200 years, had been perturbed out of the outer Oort cloud, a cloud of comets in distant space farther than 10,000 astronomical units from the Sun. The perturber, which they called Tyche, the good sister of Nemesis, see the next item, was about 1 to 4 times the mass of Jupiter. Matisse et al. helpfully pointed out that if Tyche existed, it would appear in the 2009 11 WISE All-Sky Survey. It did not. Nemesis. In 1984, paleontologists David Raup and J. John Sepkoski published a paper claiming that major extinctions occurred with a regular period of 26 million years. Two different groups of astronomers proposed an explanation. The Sun has an undiscovered companion star, Nemesis, named after the Greek goddess of retribution, that orbits every 26 million years. When Nemesis is at its closest point to the Sun, it disturbs the comets in the Oort cloud, sending a shower of comets inward. Some hit Earth and cause extinctions, such as that which doomed the dinosaurs 66 million years ago. Because it has not been seen, Nemesis would have to be a very dim object, like a red dwarf, star, or even a brown dwarf. Nearly every aspect of this hypothesis has proved controversial. Many paleontologists do not agree that extinction is periodic. Several astronomers have noted that such a wide orbit would easily be disrupted by passing stars. But the clincher is that, as with Nibiru and Tyche, subsequent surveys that observed the entire sky at infrared wavelengths would have spotted Nemesis, and, so far, they have not.